All right, we're back. Okay. We're going to, let's check out our Pokemon sound of the day. Probably up today. Let's check out the sound, shall we? Guess we'll do this one. Interesting sound. Oh, I didn't even know how to do this one. I didn't even know how to do it, to be honest, but that's alright. Okay, let's take a look at our problem of the day. See what it is. Maximum absolute of any subarray. Given an integer array nums, the absolute sum of the subarray nums 1. I'm confused what we're doing here. Return the maximum absolute sum of any possible empty subarray. Any possibly empty subarray of nums. I'm kind of confused what we're doing here in this question. Prefix sum can do it in one line. I don't know why this subarray though, like why 2, 3. I don't. If X isn't, note that added. So. What is Cadane's algorithm? I don't even know what that is. One 749. Okay. Okay. Max sum, min sum, right? Sum is equal to inf. Sorry, how do you do this? Is it like floats inf? Sum is equal to 0. Okay. Y in range length nums. Well, okay, so we need to make our code here for j, make nums. Then we do, well, max sum is equal to the sum of max sum and cur. Min sum is equal to the min of min sum cur. Right? Yeah. Then what do we want to do? We want to return the max of max sum min sum, but we want the absolute value, so we would need, I guess, like this. Max sum cur. Object is not iterable. Oh, max. Sorry, this is meant to be fucking max. Yeah. Abs takes one argument, 2 given. How do you do the absolute value then? Jeez. I'm gonna open the window really quick. Okay. Okay. I realized I did that wrong. So it takes one argument, so we need the absolute value of max sum and then the absolute value of min sum. Which is what I did, I think. Okay. What do we do wrong here? Level 6, expected 5, going to output a 3. Is it always -2? There's no way this works, but... oh, sorry. +2. Could you imagine this returns in? Like, no way this returns. Like, no shot, but... nope. Get rid of that. I'm not sure what's wrong here. I'm missing something small. Track max, positive subarray sum, min sum, current max. What? Your outer loop for is unnecessary because cur is always reset to 0. I thought it would be always reset to 0 when we move to the next number. But you're not using I inside the loop. Do I have to start from like I plus 1 or something? Oh, okay. Should be initialized to 0 just like max, otherwise min function will never work correctly. Why would float inth should be initialized to 0? Because then we're always going to have... Tell me that this should be 0. No way. Okay, how does this run? Okay. Apparently incorrect. Max sum and sub fine. Range length nums. Cur is equal to nums I. Oh, sorry for J in range. I plus 1, we keep that. Okay, I thought they wanted me to get rid of that. Let's take a look at this. Perfect. I feel like so out of it right now, dude. Okay. Apparently we need to initialize the max sum here. Max sum is equal to max sum cur. Okay, because we need to do the only value. That's right. Min sum is equal to max min sum cur. Because we're running it only for the next value, so we need to include the first as well. Nope, that doesn't work. Am I doing this right? Yes. Got the max. Oh. Check it for max here, this should be min. Oops. Okay, let's see if this works. Doesn't work. Too slow, maybe. I don't know. Time limit exceeded. Okay, so it's too slow. Okay. So how can we optimize this technically? Like, since it's prefix sum, can we do it in one pass? We can. I'm pretty sure we can just do it maybe in one pass. No. Okay. Do we really need 2 loops though? Oh, sorry, wait. Okay. If we do it and run past though. Need a cur here. Plus or equal to. Guess we would initialize this to. Well, I mean, we go through the first value here, so I don't think so. Maybe we could just do num plus or equal to nums I. Then we update our max sum. Max sum is equal to max cur. Sorry, max sum cur. Min sum is equal to max min sum cur. Sorry, this is meant to be min. Let's return the maximum of the absolute of min sum, and then the absolute of max sum. Six. Okay, we're back to where we were originally at. Do they even have Kadane's algorithm on the internet? Kadane's algorithm. Let's take a look at this. I'm not sure what is wrong here. What's wrong? You're computing a prefix sum instead of tracking subarray sums. This will incorrectly accumulate values across the entire array instead of considering independent subarrays. You need to apply Kinane's algorithm correctly. Oh, she's burped. So they're telling me that I need to track Comax. I don't even do this. I track cur max and cur min, current max and current min. Okay. Why would I have to do this? They want me to track the num. They want to track the max of cur Comax or the num. What does this do? And then here we want to compare max sum and comax and comin. So the min would be, well, we want the current num here actually. We want the num, comin plus the num, I think as well, yeah. What is this doing? So we're comparing a current number to comax plus the num. So that would be the next value. Okay, I understand. So I think here what this is going to do is that we're going to loop through this array here. We got 2, -5, 1, -4, 3, -2, right? So this current max holds the current subarray in the array as we're looping through it. So we loop through it, we start all this is all equal to 0. Max current is all equal to 0, right? Okay, we want to loop through this, so then our max, we get our current number, right? So our current number is 2. We do comax plus num. But in our first pass, we're only comparing against 2, so everything is going to be 2 pretty much, right? So our comax comin. This is an interesting way to think about it. I would have never thought about it like this, but min sum. So our comax as well, we want the max of our first number, right? So we're going to get the max of num plus comax plus num. So it's going to be, everything's going to be 2 after the first pass. I'm going to go to -5 and we're going to do, well, comax max -5. So we have our current num, -5 over comax plus num. So comax, what is that? That's 2. Plus num is -3, so we're going to take that max. The min is going to be, well, 2 comax, so -3. So this is going to go to -3. Then the max sum, we're going to do the max sum of 2 and -3, which is 2. The min sum, this is going to go to -3. I'm going to go to the next value here. We're going to go to 1. So our 1 here, well, we do the max of num, so this is going to stay the same. We do the comin, we do -3 plus 1, -2. So nothing's going to update when we go here. When we go here to -4, I'm going to do, well, -4 comax plus num. That's still going to stay the same at 2. Comin is going to be, well, -4, -3 plus -4 is -7. So this is going to be -7 now. And then this is going to update to -7. And we got 3. We got our Kermax of 3 Kermax plus 9. So finally we're going to get a 5 here. Actually, when we were 1, I think this should be 3. I think Kermax should be 3, actually. Anyway, we're at 3 now. So 3 num 3 plus 3 is 6. So we get Kermax 6. We do max sum. We got 6 here. Negative 2. 2 is 9. Damn, I'm messing this up. Let's see if this runs fast, actually. Should probably check that first. Oh, that should be I. Okay. Okay, I want this test case here. Was this the test case we used, or was it? Wait, was it? Which test case were we using? We were using this one, right? Okay. Okay, so so we were right at first. Hang on, let's get rid of all this crap. Everything is 2, right? That's what we got there. Kermax or Kermin, everything is 2. So then we process negative 5. Negative 5 plus some size. So it's only min sum that updates. Min sum would be negative 3, right? Kermax 2, negative 5, negative 3. Kermax would still update. Well, it's going to take the max value. Oh, okay. Well, it's still going to take them. Wait. So max sum is still going to be 2. That's where I got it wrong. I become max with -5, -5. So 2 plus -5. So comax is going to update to -3. -3. Min is going to be, well, -3 as well. -5. Sorry, yeah. So that means our min sum is going to go to -5 as well. Two, -5, 1, -4, 3, -2, apparently. Four. -5 plus 1. It should be -4. Wow, they got it wrong. It should be -4, and that's how we get -8. Okay, yeah. I understand. It's an interesting way. I would have never, like, I would have never thought about this, like, specific algorithm. But, you know, it's definitely interesting. Like, okay. Cool. Interesting question. Let's take a look at some of the solutions. Okay. Let's take a look at our hash tables. Let's do one problem out of the hash tables, then we'll do a couple. Already been going half an hour. Jeez, man, it goes by fast. I mean, like, yeah, fast. I don't know. Another subarray. DNA sequence. Number of boomerangs. Should we do number of boomerangs? All right, we're gonna do number of boomerangs. Let's take a look at this problem. You're given endpoints in the plane that are all distinct, where points I is equal to x. A boomerang is a tuple of points, I, j, k, such that the distance between I and j equals the distance between I and k. The order of the tuple matters. Return the number of boomerangs. I don't really know what this exactly means, to be honest. I don't know what this. You're given an n points in the plane that are all distinct. So these are points in a x and y plane, I assume. Points I is equal to X, I, Y, I. A boomerang is a tuple of points, I, J, K, such that the distance between I and J equals the distance between I and K. The distance between IJ equals the distance between IK. I still don't understand what this means, bro. I don't know what this means. Like, I don't get the question at all. To be honest, man, I am not sure. Number of boomerangs. Okay. I'm not sure about the problem statement, so I'm trying to get a little clarification here. You're given a list of points on a 2D plane. A boomerang is defined as a tuple of 3 points, I, J, K, where I and J have the same distance as I and K. The order matters. I, J, and K is different from I, K, J. You need to count the total number of boomerangs. Oh, okay, wait, hang on. I think I'm gonna have to paint this on a... This is crazy. Okay, so we have 1 point. Let's do our point in red. Why not? So we have our point here. We have a 1, 0, which I think is here. I think. 2, 0. The two boomerangs are 1, 0, 0, 0, 2, 0. 1, 0, 2, 0, 0, 0. Bro, I still don't understand, like. The distance to 1, 0. 1 squared plus 0 squared is equal to 1. Distance to 2, 0. 2 squared plus 0 squared equals 4. Oh, okay. I understand. Okay. We can form 2 boomerangs. Okay, I understand. So let's go pink here. Pink is too similar. Let's do orange. So we pick all these different points, right? And we have to check, well, a boomerang is a tuple of points I and J such that the distance between I and J equals the distance between I and K, right? So we pick a point, right? So let's say we pick this point, right? This point here is 0, 0. We have to check the distance is the same between this one and this one. And in this case it isn't, because here it's the distance of that is 1, right? And the distance of this one is, well, that formula here they talk about over here is, actually let's take a look at the distance formula between 2 points is the Euclidean distance formula without the square root, which is used to calculate the squared distance between 2 points in a 2D plane. Okay. So we do this formula. So this, we're going to refer to this as the, I mean, they were talking about that in discussion, the Euclidean whatever, like, this categorize is easy. Okay. Okay. Jesus, man. Too much bullshit on here, bro. So yeah, the formula is x squared plus y squared is equal to, I guess, the distance, right? So in this case, we start with 0, 0, so we're going to check both these. We're going to check oh my god. We're going to check the distance to, let's check the distance to 1, 0, right? So distance to 1, 0 would be 1 squared plus 0 squared, which is 1. I don't even know what this is, to be honest. The distance between distance to 0, 1, right? And we're going to check the distance to, well, 0, 2. Sorry. Gosh, man, I messed this up. 1, 0. Right? Let's get rid of this, bro. I don't even know what this is. Like, I already forgot when I wrote it. Okay, bro. Oh my gosh, dude. Are you serious, bro? Right, 1, 0. Then we want to check the distance as well. What is it? 2, 0. Kind of looks like 4, mostly. 2, 0. Alright. So then we do 2 squared plus 0 squared, which is, the distance is 4. Alright, so this would not work. Ooh, whoops, this would not work. But if we were to pick this point here, right, and this point is 1, 0, and we compare, well, how far is it to 0, 0, right? I mean, 0 squared plus 0 squared, I mean, the distance actually is 1, right? We got 1 squared plus 0 squared, which is 1. And the distance between 2, 0 is 1 squared plus 0 squared, which is, again, 1. So therefore, at this point, we have 2 boomerangs here. And again, from this point, it's going to be the same as this one. So that's the way that we got to approach the problem. So we kind of think about a 2D plane here. So we got to think about this here. How can we solve this problem? How can we translate this into code? Well, firstly, I think we create a dictionary, obviously. I mean, hash table, math. Okay, yeah. Now what we want to do is that we want to iterate trying to think here. We want to iterate through all the points, right? So for I in points, so actually for row in points, let's print row. What does this print? This should just print the, okay, we're printing the tuples here, right? So for row in points, for I in points, right? I guess we want to print I. Ooh. How can we do this? We want to take the point and how would we do this? Okay. Okay, we're gonna need a result, right? We're gonna need a dictionary. Alright. Here when we loop for j in points, print j. Some of the tuples, man, really messed me up, bro. I'm telling you. This just prints it once. Okay. Right. So let's do that. Okay, so we want to check, well, 0, 1, 0, 0. I'll get rid of this. We got 0, 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, perfect, right? So now what we want to do is we want to do, well, we need to look for the distance here. How are we going to look for the distance here? Well, the distance is equal to like J0, something like this, J0. Let's print J. J0. What was the formula? It was plus J0 times 2 plus J1 times 2. Right? Let's print out distance here. To work out the distance between the 2 points. So, okay, if we're gonna do the distance between the 2 points, then I think we go, well, I0. Right, we need to compare, because we're going 0, 0, 1, 0, 1, 0, so we need to compare from the specific I that we're at, right? So, distance is equal to I0 times 2 minus J0 times 2 plus I1 times 2 minus J1 times 2. Let's see what this gives us. We get 0 here. 0, -1. -4, 1. They're fucking up the calculation. No. Oh, whoops. Get rid of this. We put the times 2 out here. Oh, yeah, no, that's good. Okay. Well, I think that's a good start, isn't it? 0, 0, 1, 2. Okay, so this is the distance between 1 and 4, right? So then we should get 1 and 1, right? So 0, 0, we got 1, 1, 0, we got 0, then we got 1, then we got 4, then we got 1, then we got 0. Okay, so I think that's correct. That's the calculations we did here. So I think we're gonna need to move this inside of here to reset our dictionary each time. Right, so we do, well, how are we gonna do this? key for the dictionary? I don't know. All I know is after is that we're gonna want to loop after this for loop. We're gonna loop through this dictionary. Well, minus go dictionary dot items, right? I guess for I don't know what we're gonna do as a key. That's the thing. How are we gonna store this as a key? There's something in the discussion. I don't know what to store as a key. I need. Is there a hint up here? What do we? Oh no. Let me go back to my hints to solve the problem. Iterate through the pairs. Okay, we did that. Key idea. Use distance as a key. For each point I, count how many points. Oh, that's right. Use the distance. Okay, so I'm going to use the distance. I'm going to do, well, with minus go dictionary. Distance in my dictionary. Then minus go dic distance plus or equal to 1. Else minus go dic distance is equal to 1. Right? Okay, then we want to loop through, well, for key value in my dictionary. If value is greater than 2, or if value is greater than 1, then let's add it to res plus or equal to value. And we return res. Let's see what this returns. Nope. What do we get? A key error. This what is wrong with this? Oh, jeez. Why does this not work, dude? I don't know. I don't know what this runtime error finding. It doesn't like it, man. Oh, this is meant to be. Oh, let's just do res. I'm used to doing res. Let's go back. Oh, we need to get rid of this. Whoops. Maybe that could be the reason. No. Why am I getting a runtime error? I have no idea. It's likely because you're trying to access a key in the dictionary before checking if it exists. What? Is that really the reason? Oh. No way I got it, bro. Ooh, we did the problem. Let's go. Wasn't expecting that to pass just like that, but let's actually see if it submits. Nope. Nope, 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 nope. CD out. We're getting output of 12, but it should be 20. We're doing something wrong here. Okay, what's wrong about my solution? I don't know. There's an issue with your solution is when you're calculating the number of boomerangs, you're adding the count of distance directly to res, which doesn't account for the actual number of boomerangs correctly. The correct formula of boomerangs is count times count minus 1. This is because for n points the same distance from base point I, you can form n times. Bro, I have no idea what that means, bro. What the fuck? Calculate boomerangs. Explain it more. I don't know. Okay, so apparently we should be doing well. What are we doing? We're doing boomerangs is equal to count times, would it be value times value minus 1? Value times value minus 1. I guess we're doing combinations here. Well, now it doesn't work. Well, damn. Value times value minus 1. That's literally what I did. Oh, not returning anything. Return res. Okay. Oh my gosh, dude. No. Bro, what? Look at this output limit exceeded. Dude, are you serious? No way, 31. No, we don't need key here, so let's get rid of that. Does that help, then? Does key help? Please. What? For value in my dict.items. If value is greater than 1, res. Bro, what? Type error, line 19. Oh, maybe this needs to be values. because we're getting a tuple. Okay. Does this fix the runtime error? Ugh. I don't know. Getting an output limit exceeded. Getting an output limit exceeded. 31 out of 32. Test case is bust. Bro, why is this doing this to me? Fixes. Simplify the distance calculation. Ensure that you're not counting boomerangs for the same point more than once. For each base point I, dictionary should track the distance. So we gotta optimize this. By optimizing it, we can... Well, let's get rid of the... We don't need the print statement anymore. Apparently we can check, well, if I is equal to j, continue. Which saves one iteration. Let's see. Okay. Now it passes. Jeez, okay. Damn, bro, look at this guy. What a beast. This guy is an absolute beast. Let's check out his LinkedIn. Python developer, data analyst. Hello world, my name is. Damn, bro, what a beast. Kazakhstan. Damn, bro. What a dog. Nice. Okay. Cool, man. Cool. Number of boomerangs. That was a interesting problem for sure. Okay. Let's move to a binary search tree problem. Going about an hour and 20 minutes. We'll probably do one more problem. Got stuff to do. Yeah, let's take a look. Count good nodes in the binary tree. Let's count all the good nodes. Okay, given a binary tree, a node x is the tree's name good. If the path from root to x, there are no nodes with a value greater than x. Nodes in blue are good. 3, 4, 5, 3, 3. Root node is always a good node. Binary tree, a node x in the tree's name good. If the path from the root to x, there are no nodes with a value greater than x. Return the number of good nodes in the tree. So we've got to save the good node value. Are we comparing from the root, given the binary tree root, a node x in the tree is named good if in the path from root to x? Okay. So what we're going to do here, we're going to do the, let's put in our node and we're going to put in our count, right? So our count, DFS, we're going to put in the root, and we're going to put in the count. Root count, well, I guess root needs 0. I guess we just want to return, return our count. I guess we initialize our count up here and we just pass in our count. Okay, alright, whatever. Okay, so we want to check, well, oh, I need to check my email really quick. Okay. Alright. So I think here, well, we need to somehow compare our root node. I guess. Root val is equal to no dot is equal to root dot val. Maybe we can pass that in as well. Our root val, and we compare. Well, our base case is if root val. If no dot val is greater than or equal to root dot val. Sorry, no dot val. Then we want to increase our count. Count plus equal 1, right? If node if not node, let's just return. I guess this is our base, right? Then we check here. Then we do our recursive function. So we would do, well, if node dot left, then node dot left root val count. If node dot right, oh sorry, we didn't call it DFS function. We need DFS node dot right root val count. Node dot right root val count. And we return our root. Turn our count. Will this work? Probably not. Oh. So we need our root val and our count. Putting 0. Just return count. I'm not sure. What's wrong with my code? Oh my gosh, I'm comparing it to itself, dude. Jesus. It's meant to be if no.val is greater than or equal to root val. Jeez, man. Jeez. Okay. Still getting 0. Okay, apparently we don't want to pass count in here anymore. Get rid of count. Just return count. Allows count plus equal to 1. Update the max val to the maximum of the current node's value and then the previous maximum. Update the max val to be the maximum of the current node's value and the previous max val. Is that what we're meant to do? Oh. Thought we're just comparing to the root. Okay. My bad. We need to update our node.val to compare. So we do a max. Okay. Root val. Sorry, max val. Max val is equal to max. Max underscore val. Node.val. Yeah. Count is equal to DFS node.left. Count is equal to and we just return count. Return again. We need to return call DFS starting from root. Get rid of this. Let's just pass in root val here. Watch it. Initialize it. There we go. Okay. Why? Okay. Okay, I wasn't passing counter properly, and I made a mistake with updating this. That was just a total mistake there, but I had the right thought process. Frustrating, but that's alright. I'm curious to take a look at some of the discussion. If you think this is too easy, but maybe you're already very good with trees. Should be marked as easy. I love these comments, dude. It's just like, alright. Okay. We're going to do a little iterative solution here. We're going to use a DFS. Alright, so our stack. We want to pop from our stack, so what is our stack here? Node is equal to stack.pop. We want to initialize our count variable. Count is equal to 0. We have x val variable, which is 0. Oh, sorry, we're gonna initialize that. Oh. You initialize that to the root value. Compare it again, so for our node, we do, well, passing our root in here. Well, we check, well, if node.val is greater than or equal to the max val, then we want to increment our count, right? Plus or equal to 1. Then if there's node.left, we want to just increment node.left. So sorry, add it to our thing. So stack.append node.left. If node.right, stack.append node.right. What we're forgetting here is that we need to update our root value. So let's update our node.val to compare max val is equal to max val node.val. Okay, and then we just want to return our count. Let's see what this does. 3311. What are we doing wrong here? What are we thinking here? I don't know. I don't think it's gonna make a difference, but to be honest, I'm not really too sure. We're not properly keeping track of the max value. You're updating max value with the node's value after each iteration. This means that max value only reflects the maximum value seen at the current level. Okay, I understand, right? So we actually have to pass in our max val. We pop our max val. We want to check, well, we're passing in here. Count max val or associated with the value. Oops. This little pen. Oh, this. Okay. So what we were doing here, the reason why it was wrong was we were technically, if we had this here, right, we have our tree. Let's draw it. That's what I didn't realize. Whoops. 4, 1, 5. Is that we were updating. So we were pushing this value to the stack, right? So this is our stack here. We were pushing this value to our stack, and then, you know, comparing our max val, right? So this would append, this would increase our count to 1, right? And then we go to an x value, and we append this to the stack, right? 1, and we'd append 1, and we'd append 2 as well, right? And then we'd pop from the stack, right? So we'd pop this from the stack, and we compare. Oh shit, sorry, this is meant to be 4, right? We pop this from the stack, and then we just be updating that this is our max, right? So here our max is, I don't remember which one messed up, but one of them did. But we were pretty much, what I'm trying to get at is that we were just comparing to these two numbers, right? So we were comparing from the parent node to the child node, and that's all we were comparing was the max val. But in fact, we should be comparing the maximum val that we see out of all these numbers. So in this case, we'd be comparing 4 to each and every value as you compare down, I think. 313, 314. why we are appending Right, okay. So I was a little confused here when we get down to the 5, but technically once we get to the 5, right, so we have 4 here, it's going to append, what is this value here? I can't even remember. 1. So we're going to append, well, 1 and then 5, right? 5 is going to have 4 as its value, right? So we're going to add this to the count, and, you know, there's no children, so we won't add it. Then we'll go to 1. See that we're comparing to 4, we'll get rid of this, and then we'll go back to 1 on this side. And technically 1 here, its max value here is 3, so technically we'll be comparing that to here. You know, so we won't update the max value, so we're still comparing to 3 in terms of this iteration here. So then when we come back down to 3, we're comparing, well, so when we add our, we don't have a right child, we had 3, we'd add 3 here, and then we'd be comparing that to the thing, we get our last one. So that's how it works. It doesn't really matter the side that you really look at, I think. Can you show me the stack with this test case? One, 3. Okay, we pop 3, then we push the right child 4 and the left child 1 onto the stack. The stack becomes 4, 3, 1, 3. Right child first, then left child. Next we pop 1. I think we can actually honestly switch this around. Like, and I don't think it's going to make a difference. The way that we're traversing it. Let's just, I want to make sure this. Yeah, I don't think it makes a difference. It doesn't. And that's what I was trying to make. That's what I was trying to clarify over here, that it doesn't. Yeah, no, it doesn't make a difference. But, you know, I'm asking GPT, like, you know, to kind of make sure, but it's like, it can't do it. Like, so, I don't know. It's fine. I already know that it doesn't, so, but yeah. Anyway, we're going to finish the video there. I appreciate you guys watching. We'll be back at it tomorrow, so some more problems. So, see you later.